Okay, so first I'm going to just start with solving for the coefficient of friction or solving for the force of friction. Simpler problems where it's not multi-step, so, or not too many steps. So solving for the coefficient of friction, that means they will usually give you the mass or the weight, and they will give you, let's see, they'll give you either Fk, Fs, or F push. Okay, so let's see, no matter what, for mass or weight, you can calculate, use F equals ma to get the weight. Oh dear, oh dear. Okay, it's not happy. It says to get weight. Or you can go backwards to solve for the mass. We usually don't need that. We usually need the weight. So if it's given to you, that's great. If it's not and you're only given the mass, then use F equals ma first thing to calculate the weight. And that goes with drawing your free body diagram. That always goes first. Then they'll give you Fk, Fs, or F push because you need something to help you figure out the coefficient of friction. Because the coefficient of friction, that's in one of your two formulas. You've either got Fk equals mu k Fn, or you've got Fs equals mu s Fn. And remember that the coefficient is mu. Whether it's kinetic or static, doesn't really matter. It's just the coefficient is mu. Remember, that's what mu stands for. So no matter what, to figure out mu, you need the friction force and you need the normal force. And to get the normal force, it's the same as the weight. So they have to give you two things, one from this first line, mass or weight, and one from the second one. So let's go through a few different cases. So let's say, no matter what, whether they give you the mass or the weight, you'll be fine because you'll be able to calculate the weight and you'll have that. So let's just assume I have the weight. And it's just some number. That means I've also got the normal force because they're the exact same thing, just in different directions. Then let's go with Fk in this first one. So say I've got Fk over here. Then I can have that in my picture. You may or may not have an F push, but if you've got Fk and you have Fn, you can automatically just go straight into this formula right here. The Fk equals mu k Fn because you have enough information. You have the normal force, you have the kinetic friction, you can solve for mu. Plug everything in. Okay, so then the second case would be if you're talking about static friction. Say we've got the weight, we've got, we've got Fn. If you have Fs here, you may or may not have an F push. I don't know, it depends on the question. Usually we do, but you never know. If you have Fs, again, you have enough information because you have Fs, you have Fn, you can find mu s. You have two of the three things, that's all you need. Okay, so then the trickier one is say I've got the weight here, I've got Fn, and I have an F push. Then we come across a little bit of a problem. They will generally tell you it's a constant velocity. So let's assume here it's a constant velocity. Constant velocity means that all the forces have to be balanced. So that means the F push and the friction have to match because they're going opposite directions. So going this way, I will have, we'll go with Fk. Fk or Fs. We don't know. Could be either one. So if it says constant velocity and it gave you F push, you know Fk or Fs because it has to match F push. So then you have enough information again. It's almost like it's one of these two that I just drew already. You have Fk, you can and Fn, you can solve for mu k. You have Fs, you have Fn, you can solve for mu s. So that's if it's a constant velocity. I'll get into more complicated ones if you're given an acceleration. That's harder. We'll get into that. So let's do an example. Let me add a page here. I don't want to do one from the quiz. Let's see what I got. Okay, here we go. Well, let's go in order. We'll do one that's FK first. So let's say nope, I don't want to push it. Hang on. Okay, that's super basic, but if they give you the mass and they give you the friction force, we'll do an example. Okay, so remember the checklist. Identify everything you've been given. So we've got mass is 50 kilograms. Fk is 10 newtons. That's all I was given. Then what was next on my checklist? Then we had any important formulas, so I'm going to use F equals ma or Fk equals mu k Fn. Because I only had those three choices, and I'm not really going to use kinetic and static in the same question, but here I'm using kinetic because that mu k had a k. So, those are my two formulas. Let's see, so I've got Fk. If I want to go, let me go over here and see what all I've got. So Fk, I know this one. Mu k, that's what they're asking me in the first place. So I know that that is going to be a question mark. And Fn, I don't know that one yet. That's not in my list of information I was given. So that's where I'm going to have to go back to what I was given and see if I can find Fn from that. So that's where I'm going to use F equals ma to calculate the weight. Because the weight matches the normal force. So, there you go. Okay, the weight is the same as the normal force. So I'm going to use F equals ma. F is the one I don't know, because F is the weight. Mass, they gave me that one. And acceleration, I guess this could have gone in my list of information I know. It's gravity, because weight is the force of gravity. So if you're ever calculating weight, you're going to use acceleration of gravity. So once you have those things, then you can figure out the weight. I have enough information to do that. So let me find my calculator. Okay, 490. Remember to put your newtons there. Okay, so this is really Fn because it's the weight, and the weight is the same as Fn. So I'm going to go put this right there, so then I have enough information to solve for mu. I have two of the three variables, then I can do it. So I'm definitely going to run out of room. Let's go down here. Okay, plug everything in. Fk is 10. Mu k, I still don't know. Fn is 490. Okay, and then remember our algebra skills, they're being multiplied, so I'm going to divide. And if I do that, 0.02. And mu doesn't have any units, so just leave it at that. Okay, and once you've got mu, you know that you're done because that's what they were asking for. They wanted what's mu k, and we just figured that out. Okay, so this one is a little bit trickier because I didn't just give you the weight at the beginning, I gave you mass. So it was an extra step here where you actually had to calculate the weight and the normal force, but it's still the same principle. Once you have Fn and you have Fk, you can find mu k. Okay, let's see, what was one of the other ones? So that would work the same as if it was static friction. It would be the exact same scenario. Let's do one where I give you the push instead. Okay, so it's going to be similar. Okay, so this time I gave you the push right there, and I gave you the 100 kilogram box. So let's write all these things down. Write everything you know. I know the mass. I know F push. I don't know mu. I can write that down that I don't know mu. Because that's something they gave me. Oh, and then the other thing is that it's constant velocity. So write that down too so that we remember. And then because of constant velocity, that means that F push is going to equal Fk. So I can just go over here and write F push is going to equal Fk because then my picture is balanced. F push is to the right, Fk is to the left. If they equal each other, then I have a constant velocity. So that constant velocity really told me all that. Okay, then I'm going to write my formulas. I will need F equals ma because I didn't give you the weight. My bad. And then I have friction. Okay, and I'm using Fk because I'm asking for mu k, not mu s. Okay, so now that I have all that stuff written down, I'm going to look at what I know. So let's see, I'm looking for mu. So that means in the end, I will want to use my friction formula because that's the one that has mu in it. So I'll just start there and see if I know enough information. So Fk, don't know that. I wasn't given that anywhere. I know that Fk is the same as F push. Actually, you know what? That will help me. Fk is let me erase that question mark. Fk is F push, which is 80 newtons. I gave you that part over here. So now that I have that, I have Fk, mu k. Well, that's the one I already knew I was looking for, so that's good. And Fn, we will come across the same problem. I don't have normal force, I don't have the weight, but I have the mass. So I'm going to have to take a step back and go back to my F equals ma to figure out the weight. That should really be my first step, but you can start. Sometimes they'll give you mass as like extra information, but start with what you've got. You can start with the friction over here that we were doing. And then, but it is always good to calculate weight, so we'll have to do it at some point. Okay, so F is the one I don't know because F is weight, and that's what I'm looking for. M, oh, they gave me that, 100 kilograms. Acceleration, it's gravity, so acceleration is 9.8. The weight is the force of gravity. Okay, so once you have those things, plug it all in. Let's see what I got. That is 980 newtons. Don't forget your newtons. Okay, so that's the weight. So that's really going to go over here because the weight and the normal force are the same measurement. So I have the normal force now. I have Fk, I had that all along. I have enough stuff to figure out mu k. So let's go do that then. So Fk, I'm going to plug it into my formula. Let me write my formula down again just so I've got it here. I can see what's going on. Okay, so Fk, 80 newtons. Got that right there. Mu k is what I don't know. Normal force, we just figured that out, is 980. Okay, so now you can go ahead and plug all that stuff in. Oh darn, I need more space. Aha. Okay, I got 80, mu k, 980, and they are being multiplied right now, so that means you would divide, and I get, I don't know that one off the top of my head, 0.082. Okay, and there's no units for mu, so that's it. Okay, so those ones, that's how you calculate the coefficient. There's not too many options. You either have a push, like this one, or you were given a friction force. And so that would be the end of that.